Okay, let's see. The date is October 5th, 2018. This is the regularly scheduled Friday class of ITSC 2309 at Collin College. And let's see, I regret that I was not able to be with you last week. And the thing that I notice about if I have to miss a day, I notice that students will take the next day off. They figure if I miss a day, well, they miss a day too now. You're still responsible for what I say in lecture. Those of you who are not here, quite a few of you I see. Let's see. Okay, so where were we going last week? Well, let me go ahead and announce we are ready for test one. No, it's not coming today. And we're going to do test one online. And I have enabled the practice test. Now, the practice test is not worth a whole lot of points because I'm going to give you the answers to it. I do expect you to do it. Now, there will always be somebody who will say, oh, I forgot to get it turned in on time. And if you don't get it turned in by the due date for the practice test, you just lose a couple of, what I think it's 5 points or something like that. So the practice test has a drop dead due date. And no, I'm not going to take it after the test. It doesn't make any sense. So I encourage you to do the practice test. People who do the practice test find that they pretty well know what's going to be on the test. So instead of asking me what's on the test, do the practice test. And the answers are, or either are or will be published. I usually leave them unpublished for a couple of days, but you can just close your eyes and not look at them and see what you need to take a better look at. Let's see, what else? So I expect to enable test one such that you have 2 weekdays and some of a weekend to do it. Hopefully I won't have your work days all the time, but it doesn't seem like there's any time I can do it where I'm not going to hit somebody's work day. After this semester, I believe we're going to go, even the online class is not going to be a true online class. It's going to be a hybrid class where you take the tests in class. So that'll be the day you have to come in. Okay. What else? Okay, now for the what we were doing last week, we talked about the outer join, and I wanted to cover that. I will give you a copy of this file. I'll post this file to the announcements when we go. I've got a file here, and I'm creating 2 tables. I'm naming my tables right table, left table. It's just names I chose. I could have named them phi and phi, but I named them left and right because that's the way I'm going to put them into the query. Now, I create some stuff here, left table, and notice that I am not naming my constraints. Why do I make you name the constraints? Because you're taking a first class in SQL, and in the first class we name the constraints. When you take my advanced class, you won't have to. Hopefully you will have learned how to if you need to. Why do we name the constraints? Why don't we just say int, give it the field name and the type and say primary key? Why not? What happens if we violate it? We get an error. If I violate it and I'm in any database, now SQL Server is very good about giving you lots of information in their error messages. If you went over to Oracle and were working in the command line, which is just a black DOS window, into which you type or copy and paste usually your SQL, you don't see much. You just see a very cryptic error message. You don't see much at all. So if I hit that constraint, I will at least see the name of the constraint and I will know where to go and find it. A constraint name has to be unique in the database. So when I see that constraint, I I will know where it tells me something. It tells me what table it's in, and so the table name underscore PK would tell me what table, and that I hit the primary key or violated the primary key. I create the right table. Notice we got a right primary key, right value. I don't know why I put that in there. I'm not really using it. And then I got LTPK. Notice that I did not place the foreign key constraint on it. Logically, it's a foreign key. I'm going to use it as a foreign key. Whether I put a foreign key constraint on it doesn't mean that I have to use it as a foreign key one way or the other. Right? I put the constraint on it. That means that it's going to check that before I can put something into that field, it has to be in the parent table. Well, I want to put invalid child in that. So logically, it's a foreign key. As if I went in later, I can go in later and say, okay, make it a foreign key, alter table, right table, add the constraint foreign key, and give it the add constraint, name it, foreign key references, what was that, left table? Okay, so I can add it later. If I add it later, it won't check it, unless I tell it to. Well, it's one of the problems for those of you who have taken the ITSW 1307, I believe it is, the access class. Shelley Cashman textbook, you just start out throwing data into the tables, and then you try to go and add that foreign key later. Somebody always has a typo in that foreign key. And then, nope, sorry, you can't add the constraint. And I say, no, you do the constraints first. So I really should have line 19, really should be a foreign key. But I want to put invalid data in there. So let's see, I'm going to insert into left table. This is the parent table. The values 1A, 2B, 3C. All right, easy enough. And then I'm going to insert into the right table. Primary key of 9Z is a child of 1. Primary key of 8, value Y, is a child of 2. Primary key 7 in the right table, value X has an invalid foreign key. Okay, there is no 99 in the parent table. So if that were a foreign key, it would not accept that, but it will just fine. So the one on the left that says 3C is childless. And the one on the right, let me and the one on the right, let's see, the one on the right, 7 with a foreign key 99 is invalid. Okay, so there we have it. I've mentioned that. Now, if I do an inner join, okay, if I say select it, what will I see on the inner join? Only those records that participate in the relationship. So what records am I expecting to see from the inner join? Which ones participate in the relationship? Well, record 1 pairs with 9, record 2 pairs with 8. I will see only those 2 records, and is what I'm expecting to see. So let's run him, execute, and notice that I do in fact see that. I could blow that up in Excel, but that's what I see. I see 2 records, the ones that are actually parents that have children. Okay, listen up everybody who is listening. Here or recording, you're going to be held responsible for this, whether you're listening or not, so it is important to follow it. Do not write left table as L, join right table. Now, it will work. It will not work in here. It will not work in the introductory SQL class. The reason it won't work is because I'm teaching pure syntax of SQL here. If you clip the syntax, it will usually work. I say usually, meaning in all of the databases I know of that come right to my mind, Oracle, MySQL, you can just say table A, join table B, and it gives you an inner join. Yeah. And if you should you decide to that you want more SQL and decide to take my advanced database programming class, you can get away with that in there. Because we know the platform we're on, we pretty much have to in that class. So you can get away with saying join. The only thing that it could be is an inner join, so it makes it inner join. The other thing that you can do later, where it says when you rename the tables, you can drop the as. So you can just say right table R, no comma. Okay. You can drop the as from the select line also. When you're aliasing it in the select line, if you just drop the as, it will assume it's there. No, if you don't put a comma between it. You put a comma between them. If you replace the as with a comma, it won't work because that's not a field. So you can get away with shortening a lot of stuff. We're not going to shorten the syntax in here. Okay. So I'm going to return papers if you say just plain join. And I do that, well, I told you why I do that. I do that because I enforce the full syntax, the pure syntax, in this class. And then after this, if I'm teaching a graduate class, people are going to write SQL the way that they want to, and that's fine. All right. Notice that I have a left table. I have a left table, which I conveniently named left table, and a right table, which is named right table. Question?
So, when we did inner join.
This is an inner join.
Yeah. So the primary key and foreign key, when we have constraints, and I noticed that even though they were named same, the primary key and foreign key, they
yes.
join work. But in outer join, remember I emailed you, it was showing ambiguous name. And
okay. The reason it's showing ambiguous name is when you do a join. The question is on the ambiguous name. The left table has a field in it named LTPK. The right table also has a field named LTPK. If you are selecting the same field from the field with the same name from two different tables, you must qualify it with the table name. So in this case, the table name, I use the alias because if I alias the table name on the from line, I can use that alias in the select line, which is why I do it. I don't like typing. So I have to say L, because that's its alias, L.LTPK, and then I have to say, and since the right table has a column of the same name, if I just said select LTPK, it wouldn't know which one to select.
So even in inner join, you have to alias it?
Anytime you're putting if the field names are the same, I keep my primary key, foreign key pairs named the same if I can. Can't always do it, but I try to. Okay. Sometimes I will have two foreign keys referencing the same field in the parent table. In that case, obviously, I can't name them the same. Okay. So you have to qualify it. If you have fields that are named the same, and so in the join, any kind of a join, if you have two fields that are named the same, you will have to qualify which one you want. And that's what the ambiguous column name means. Okay. So I have a right table, I have a left table and a right table. The left table is the first one that you type as you're typing along from left to right. It doesn't matter if you break it to another line. If you break it to another line, it's still the same thing. So it's logically it's on the left. The other one is logically on the right. There's nothing about that table name that makes it be a left and a right. You could switch them just fine. And if on an inner join, if you switch them, it would not make a bit of difference. They're all the same. Okay, that's one of the properties of an inner join. Inner join, there really isn't a left and a right. It's just, they're just there. So this would work the same way. If I switch them, I wouldn't be able to tell the difference. Let's move to the outer join. I've got a left table and a right table. A left outer join is, I say it is pointing to the left table. It is pointing to the parent table, okay, which happens to be on the left. Okay. Now, again, you can get away with sometimes saying left table as L, left join. If you just say left join, well, it can only be left outer join, so the system will accept it, your teacher will not. Okay, so you have to write outer in this class, left outer join. So what this means is that we will get all rows from the left table, whether they match or not, and participating rows from the right table. So if I ran this, should I blow that up? Can you see it okay? All right, the output then says, well, we get the left pk of 1 participates in the relationship with the right primary key of 9. Left pk of 2 is paired with the right pk of 8. So 8 is record 2's child. Record 3 has no children. Yet we see that record anyway. Questions? It points to, in this case, it points to the parent. Now, what would happen if I interchanged the two tables? I usually put the parent on the left. That's just kind of my way of doing it. But what would happen if I put the parent on the right and used a right outer join? I would have the same thing. Okay. Some systems do not give you a right outer join. Some systems only give you a left outer join. I believe SQL, MySQL used to be that way. I don't know whether its current releases have added. I've heard that its current release added a right outer join, but used to be they only had one, and you just had to put the tables on the right, on the correct side. Again, don't say left join. If you write join, J-O-I-N-E, the word that comes before it has to be either inner or outer. Okay, this is the childless parent query. Let's take a look at the childless parent query. It's essentially a outer join. I'm going to call it a left outer join. If the parent table is on the left, it is a left outer join. If you put the parent table on the right, it's a right outer join. But since I put my parent table on the left, just by convention, I mean, if I have method to my madness and I do it that way, you'll find it's generally easier. If you want to put it on the right, you can put it on the right. I didn't tell you where to put it. My outer join points to the parent table. If I'm trying to find childless parents, I want all of them. So can I see in this output, can I see the childless parents? Let me copy with headers. I'm going to go over and drop it into Excel if I have an Excel page. Can I see which parent, by looking at those data, can I tell which parent is childless? Yes, obviously it's the one null, okay? Thus, a very common task, a very common use in fact, the most common use for the outer join is finding the childless parents. Let's take a look at a childless parent query, okay? I do not need to select anything from the right side of it because the right side is all going to be null. Okay? Because I'm only selecting from the left side, I still have to qualify it. Even though I'm not selecting it, I have to qualify it because it's in both tables. So it could be either one. But these guys on the right side are always going to be null. Therefore, I don't need to select them. Left table as L, left outer join, right table, pointing to the left table, which happens to be the parent, where the right side, the primary key, I could have also said the foreign key would have worked, is null. I usually talk about the primary key when I can. If I had said the right side foreign key is null, it would also have worked. The primary key is better. If I run this one, I see only the primary key of the childless parent, which is what I wanted, probably. Might have wanted some more data from the parent table, but I don't have a child table to take data from if I'm only interested in childless parents. Now, it could be that you're interested in all parents, period, and childless parents. It could be that you're taking stuff from both tables, so it could be that the where is null. It could be that this where you might not use it. You might want to take all the information from the parent table, and you might want some information from the child table at the same time, and just let it be null on childless parents. Okay. So there might be a difference in what to do, on what you choose to do. Questions? You can pretty well count on having a childless parent query. Ask yourself, what is it? So that's the big question you get asked for that calls for an outer join. If you talk about a left outer join, meaning a left outer join, when I say a left outer join, I'm saying it points to the parent. It points left. If your parent's on the left, then you want a left outer join. Now, this one, now it starts to matter whether you, in what order you put your tables. Yes?
You said if you have like the word left, the word after it has to be inner or outer. What would be a left inner join?
There is no such animal as a left inner join. That's why you can get away with just saying left join, right join, or plain join, because your if you say inner, if you just say join, the only word before it could possibly be inner. If you say left join, there has to be an outer between them. So since there's no such thing as a left inner join or just a plain outer join, it's either left or right. I'm going to talk about one. There's one more in there called a full outer join that we don't use very much. And I'm not going to put that one on the test, but I'm going to just talk about it. You might need it for something. Okay. So basically, when you get to the outer join, the order of your tables matter now. If I switch the order of the two tables, then I switch the left to the right or right to the left, something like that. I always put the parent on the left, the child on the right. I don't know whether it's easier. It gives some method to the madness.
I would rather put parents on the right. It makes sense.
Okay. Well, person after my own heart then. I try to, when I code in any language, I try to come up with coding conventions, and they don't necessarily rule my whole life. If I need to violate them, I violate them. If I need the parent on the right, I will jolly well put the parent on the right anytime it makes me happy. By the way, you can mix and match inner joins and outer joins. The outer join is the reason that we stepped away from, which I talked about in the last first half of this chapter, we talked about the old implicit syntax, where we just say table 1, comma, table 2, where the primary key of table 1 is equal to the foreign key of table 2. Remember that? So we linked them in the where clause. That's fine. It works just fine. Everything's okay with that. It always works. And so if you just did, in fact, I love implicit joins. The only reason I go to the longer syntax is because I'm teaching SQL. But so I'd be just as happy staying with the old syntax. But when you get to the outer join, the syntax, the way it did it, evolved differently in different languages. Some of them used a plus, some of them used an asterisk. So you say table 1, comma, table 2, where table 1 dot foreign key. Sometimes they said plus, equal, sometimes to mean a left outer join, and equal plus meant a right outer join, and some of them, instead of a plus, they used an asterisk, and some of them put the plus in front of the field name, and some of them after, and basically nobody knew what the syntax was for it. So every one was different. What we want, the theory is that SQL is supposed to be SQL, by gosh, by golly, it's supposed to run in any SQL platform. Therefore, we developed the different one of outer join, left outer join, right outer join on. Okay, now it's clear. It is not true that SQL is SQL and it will run. But if you're writing in pure SQL, it should run on any platform. So if I pick these guys up and drop them over into Oracle, I should get exactly the same output. In fact, we're doing Oracle right now in the other class. Okay. So look carefully at the childless parent query. I'm going to put this out for you. And here we have it. Let me turn on. A lot of participants today. Unmuting everybody, unless you have muted yourself. Are there any questions from the online audience? Can you hear me? Anita, are you there? Somebody speak.
No questions.
Hello, Doug is here. I can hear you.
I see you, Doug. Questions? Anybody? Okay, I'm getting a little bit of microphone noise, so I am going to mute again. But I'll turn on the microphones from time to time. Okay, going on. Excuse me, the right outer join. Okay, so this is this is the same selection. The only thing I did was change the left outer join to a right outer join. Now I have the outer join pointing to, I say, the child table, if the child table is on the right. But it points to the right. Now, what will I get? It's going to work the same way, just left hand, right hand difference. It's the only difference. So now I'm going to get everything from the table where it's pointing to the right, and only those records that participate from the left table. Okay. So if I execute this, I expect to see 3 records. Okay, notice that the left primary key is null. What does this tell me about that particular one? Well, I can look at it pretty well and tell you what it is. Why is that left primary key null? Correct. It has an invalid parent. Now, when I have an orphan, I do not have to use a join to find orphans. Okay. I do not have a right outer join where it points to the child. So an outer join pointing to the child, that's better than saying right outer join, even though my child is on the right. I do not need an outer join to find orphans, although it will find orphans. I can find orphans by just looking at the child table. I don't have to look at the parent table to find orphans. Orphan is a child record with a null foreign key. Foreign key can be null. There's nothing stopping it in a database from being null unless you have constrained it as not null. So it would happily let me put in a null value there, but all I have to do is look at that right table where the foreign key is null. I don't have to do a join. It is considered an error in SQL to join tables when you don't need to add extra tables to a join that aren't required logically. So if let me go ahead, I'm going to go ahead and put in let me put in an orphan. Let's add an orphan. That's going to be 6. Well, would help if I put the parentheses. So that's 6. Primary key is 6. The value in there is a W. And the foreign key, what's logically being the foreign key, is null. Execute everybody there. Okay, and let's see, left outer join, or down to the right outer join. Notice that when I execute this guy, I see if I looked at the right table, notice that I get the orphan. So the right primary key of 6 is an orphan. And I see that in the right outer join. But I don't have to do an outer join to find orphans. I will find orphans in the right outer join. But if my objective is go show me all the orphans, that's easy. Okay. Yeah, that's one table. So I look at that right table where the foreign key is null. Boom, I've got the orphans. Questions? Okay, invalid foreign key query. This one is going to return the orphans, by the way. And then I'm going to ask the question of, well, what if I don't want to see the orphans? I only want to see invalid foreign keys. I'll talk about that one. If I'm looking for invalid foreign keys, my left side is going to be null. I don't need to print the left side. I'm just going to print null there. But if you want to see it, fine, you can see it. I took it out. I only want to see the right primary key, and I want to see the offending value, the one that's invalid. And that's usually what you want. From left table, right outer join, right table. On is the same, and where the left side is null. This one I have to order by the right primary key. Up here I was ordering by the left. I do not have to alias RTPK. Why?
Because it's the only one.
Only one. If the names are, that would be an argument some people might say for not naming the foreign key the same as the primary key. Okay, I hear that argument. I mean, I'm suggesting keeping them the same. In our examples, they're the same. So get over it. But if you don't want to name them the same, you don't have to. So when I execute this, I'm going to see 2 of them, right? how can I suppress that orphan? I don't, if I get a lot of clutter in there, and so I'm looking at a table with a gazillion lines in it, and I just want, the only thing I want are the invalid foreign keys. By the way, what's one thing that you will do? People will do it like they did in the Shelley Cashman book in the ITSW class. They just throw data in there and they get a lot of typos in it and they have a whole bunch of invalid foreign keys. Now you're coming along, you say, I'm going to clean this table up and I'm going to make it have a foreign key. But before you can make it have a foreign key, you have to find the ones that do not conform and do something with them. Okay. Set them to null. What could you do with those records? Just let me finish. Let me finish this one. I'm going to go back to that question. Okay, how can I suppress this? The line 1 there that has the null foreign key. That's an orphan, and row 2 is an invalid foreign key. I want to suppress those orphans. I don't want to see orphans. I'm going to turn on my participants. Okay, you guys out there in internet land can participate in this too. If I wanted to suppress these orphans, the orphan is row 1, so go back up here. I'm going to do just the plain right outer join. Execute. Notice I got 4 rows. Left primary key and the right foreign key are null. And this one, row 2, is an invalid foreign key. Notice he has a null left foreign key. And the rest of the rows 3 and 4 are participating in the relationship. So everything's fine with rows 3 and 4.
So which ones are you trying to get rid of?
I'm trying to get rid of that orphan, because if I'm only interested in finding invalid foreign keys in the right table.
Can you say that where right foreign key is not?
Okay. That is the correct answer. Anybody else want to take a swing at it? Okay. I'm going to go ahead and mute again.
I'm sorry, I have a question.
Go ahead. I have a question.
Okay. So you're looking for the ones that where the right foreign key is not null, but it's
correct.
It's just not there.
Correct. I'm being asked. I'm asking for invalid foreign keys, but not orphans. An orphan isn't invalid. Orphans don't bother me. I mean, unless there's some other constraint that says, if I say orphan has to have a parent, no orphans, then I constrain that field against null, and now they bother me. But I can find orphans by just looking at the right table. That's pretty simple. Okay, I'm going to change this to and. RTFK. Well, no, I can't say RTFK. I have to say R dot LTPK. So I have to fully qualify it and use its name, because I don't have these aliases from the select line. I don't have them yet. Okay. I don't have those select aliases. Down, I would have it on the order by line. But remember the order of execution. The where come, excuse me, the from is first. Anything that's aliased on the from line can be used anywhere else. The where line is second. Finally, the select line happens, and then the order by happens. So if I were to execute this, now I will see only invalid foreign keys. What might I do with these invalid foreign keys? I'm trying to fix this, and you're saying what? Add a record of 99 to the left table. That would be a fix. But what if I have a whole bunch of them, and so I've got them all over the map. I really probably don't want to do that. One of the things that I can do, is I can put an entry into the left table, and I hope I have an entry that is not a valid record. For example, I could make the primary key of the left table, the parent, be -1. Well, that's an integer. Nobody probably has that number, maybe. I don't know. I'm hoping I can get something like that. Then I give that the name of parent of orphans, and we write that typically when we talk about it. It's logically it has a name, capital P, lowercase o, capital O, so we don't spell poo. It's vulgar, some people think. Parent of orphans. Now, if I have an invalid key, I don't know what to do with these. I'm going to give them -1. That way, I don't throw the records away, and now they have a valid foreign key. So I'm just going to say update them, set the foreign key. I don't know what it's supposed to be. I don't know how it got there. I don't have a history on it. Well, I do, but it's a lot of trouble. So I just set them to something where I keep those records, and then I can go back and find them anytime I want. And I know that when I have a -1 in there, it belongs to the parent. Maybe parent of orphans would be like 0. So if he's really an orphan, I'll put 0 in that field. And then if it's an invalid foreign key that I don't know what to do with it, I have to do something with it, I'm going to make it a -1 possibly. So we have some method to our madness. We have a thing that makes sense that we're doing. So I'd probably give that guy, instead of 99, I'd probably make him -1, and I'd have a record up there called invalid parent.
So then now these will all show up in an inner join, right?
Yeah, they would all show up in an inner join, which is why I like that approach. Now I don't have to have an outer join anymore. Okay, the main use for an outer join. Two big uses for outer join. Well, anytime I want to see all the records from one table or the other, I use an outer join. The most often time that will be is you want to find childless parents. So you're doing something that involves childless parents. You need to get them in the output, and or exclusive, or you're looking for invalid children. I'm saying most of the time, if it points to the parent, you're going to get childless parents. If it points to the child, you're going to get invalid children. There's one more that we don't use as much. The textbook mentions it. I'm just going to kind of do a quick drive-by on it. SQL Server and most others now give us something that is called a full outer join. What is a full outer join?
Is it a Cartesian product?
Okay.
It's completely
It is not a true Cartesian product. Okay.
So does it find both childless parents and orphans?
Right. It shows the records that participate in the relationships. And it shows and also you will have one row each for childless parents, and you will have one row each for invalid. A full outer join will also have orphans in it. But the orphans will have a null foreign key. So I can tell an orphan from an invalid by looking at the record. questions? What time are we? About 10:45. I'm going to talk about something now. Let's see, we are at 10:45. So we're going to go to a break here in about 4 or 5 minutes. I'm going to refer you to a page in the textbooks. Oh yeah, the in the textbook, let me outer join is not restricted to 2 tables. Page 144 talks about outer joins with more than 2 tables, where they work a lot like inner joins with more than 2 tables. You can mix outer joins and inner joins. I believe I have one in the exercises that's like that. I don't recall exactly. Combining them. Page 146 talks about combining inner and outer joins. Page 148 talks about a cross join. Now, a cross join is a full Cartesian product. Okay, so it's like joining table 1, table 2, and just say joining them, make every possible combination. Now we're kind of back in the realm of just putting the 2 tables in there. Table 1, comma, table 2. You get the Cartesian product if you don't have a where. And that is what a cross join is. And a cross join is, I usually use the implicit syntax when I do a cross join. There's no particular reason to go to the full one.
So just like you just took away the on statement.
It is like saying an inner join or just a join with no on statement, where it's going to make every possible row. So if I have rows in, if table 1 has values 1, 2, 3, and table 2 has A, B, C, I'm going to get 1A, 1B, 1C, 2A, 2B, 2C, 3A, 3B, 3C. Every possible way to put them together. That is a cross join. Or a Cartesian product, I prefer, but yeah, there are some questions sometimes that might be useful. If you get out of here knowing what knowing an inner join gives you everybody that participates in the relationship. An outer join, a left outer join, gives you everything in the left table and everything that participates in the relationship, unless you say where the right side is null, then you'll only get the unmatched records. So an outer join gives you unmatched records. And just if you just say a plain outer join, left outer join, right outer join, you get all of the records from the table it's pointing to, and you get all of the records. And then on the right side, you're going to get every matched record, and where they don't match, you're going to get null. Okay. The most useful part of this is finding childless parents and finding invalid foreign keys. Go ahead with your question.
So look, when you do the cross join, like you said, the A, B, C, 1, 2, 3, will you also get A null, B null, C null, and
yes.
null, 1 null, 2?
Mm-hmm. So if you have null values in a cross join, they're going to show up in there too. I think. So if you had a null foreign key in a cross join, you'll definitely get them. That's the problem with cross join. It gives you such a big wad of data. It's hard to figure out what it is you're trying to get out of it. I don't have a good problem with a cross join. I don't think they try to give us a problem where we would use a cross join. I can't think of one. The only way I would use a cross join is to follow the syntax. Okay, they give us one more that's mentioned is the full outer join, and it's almost never used. And I'm going to stop and take a break because it is 10:50. Okay, we're going to take a break until 11 o'clock. I'm going to pause the recording. Let me unmute for a minute. Okay, we're going to take a short break here. Anybody on out there in internet land want to ask a question?
I do.
Who is this, Doug?
This is Doug.
Go ahead.
I was curious on the code that's displayed on the screen right now. Could you have used, instead of is null, is not null, could you use the equal sign and the not equal sign in place of that? Would it still work?
The answer is no, not logically, because equal means the same thing as, and null means no thing.
I see. That's what I was wondering.
Equal to, not equal to, greater than, less than, do not apply to null. You can only say is or is not.
Okay, got it. Thank you.
This is not true in all programming languages. Other languages will allow you to say equal to null, but SQL does not. Okay, I'm going to pause the recording.
Hey, Doc.
Resuming the recording. Okay, I've created a couple of select queries here, and I am now on page 150 of the textbook, and so this is now for something completely different. And let's see, it's getting a lot of microphone noise, so I'm going to mute everybody.
Is this next section on the test?
It is possible that it would be. If it is, look in what you see. The question comes up about the test. I'm going to talk about the test here in about 15 minutes. So give you all the about the test you want to hear. Okay, just a couple of plain old select from where, single table, select from wheres. They don't have to be single tables. So if I execute them, I see everything, all the data from the left table. If I do the right, I see all of the data, except I didn't put the foreign key in there. I'm not really interested in foreign keys in this exercise. So if you look at page 150, the topic on page 150 is unions, and I do not have this. I don't think I have written this into the module yet. This was added new to the textbook. So I am going to put this into the module. Now, I have two select queries. They are similar in that one of them selects LTPK, the other one RTPK, and they are the same data type. So the first record from each one, the first row return, the first value column returned from each one is compatible. They are both int. The second one, LTVal, RTVal, is compatible. They are both char. Okay. As long as they are compatible, they return the same number of columns. Both of them return the same number of columns, 2 columns. If one of them returns 2 columns and one of them returns 3, you can't do this. But if I engineer them such that they return compatible data types, by compatible, I mean that if the one on top is larger than the one on the bottom, I think it will work, but not the other way around. So the one on top is going to set the size. If the one underneath is smaller, I believe it will still work. For example, if the one on top is a char 16 and the one on the bottom is a char 10, I think it'll still work. It usually will. Okay, if I do this, lose the semicolon, union. When I do a union, I typically indent the selects. I like this format the best because that shows me I see what I'm doing better. So when I say union, what does union mean? Combine. Give me those rows that are in both, are in either table. Okay? Go ahead.
Yeah, wait, so is this union like the math that union?
Yes, yes. Mm-hmm.
So
It is a set union. It's not.
so if they're both tables, it won't show double.
Well, the question is, will it show doubles? And the answer is, it depends. Okay, and I'm going to talk about it. What does it depend on? But this goes to the math idea of the union, set union, because database works with the idea of set theory in mathematics. So a database table is a set of data. If you look at the restrictions on it, that there be no duplicates. In mathematics, when you have a set, you do not have duplicates in the set. So this is why we don't have duplicate rows in database. It tends to bomb our theory. Now, there's nothing about database that stops you from having duplicate rows, but in theory, it doesn't. Okay. Now, when I execute this union, I'm going to get everything from this table and everything from this table if they are compatible. If they aren't compatible, I'm going to get, for my reading pleasure, an error message. Okay, I'm going to execute this. And notice I got everything 1, 2, 3 from the left table and 6, 7, 8, 9 from the right table. Notice the field names. Okay. In a union, I've got one that's on top and one that's on the bottom. What about the field names? It took the field names from the top table. That's what gave it the field name. The field names do not have to match. If they match, fine. And generally speaking, in a union, I would have, if I were going to do a union, I'm setting up a union, I would have given them, I would have aliased them in the second table, the bottom table, and I would have given them the correct name just because I like to do it that way. I do not have to have the same name. If they are not the same name, it will pick up the name of the top table. Okay. So, get them all on the screen. So notice the name comes from the top table. The values, these values right here came from the top, and these values here came from the bottom. Okay.
So it won't list the bottom table as
Field names, no. No, your field names come from the top table.
only ever.
Yeah.
So why would you write select them? Just to pull that record?
Why would I alias the bottom table in the select line? I don't know, because I'm anal about it, I guess. Because I just I don't know. I don't have to. You don't have to you don't have to make the bottom table's aliases agree with the top table. If you don't, you don't. Yeah. I don't have to qualify it in a union because they come from two separate select statements. So a union puts together two select statements and makes them one. Okay. If you questions from anybody out there? Pausing for questions. Let me check and see if I got a I don't see anything new in my inbox. I don't see anything new, so.
I think some people are posting their questions on the chat button at the bottom of the screen.
On the what now?
There's a chat button shown at the bottom of the screen.
Yeah, I've never used that chat. Let me go over there and see if I can. And under chat,
I think if you click at the conversation, the thing at the bottom,
I'm sorry, say that again.
the icon at the bottom, you might need to click that one to get the chats that are already going. It's in orange on my screen.
So you're seeing the chats?
Yes. If I click that orange thing at the bottom, it says chat.
See if I can find it. Meeting
Scroll
control.
down.
Scroll down. No, I'm in. I need to go back here.
See that it says chat 14.
It's within
Here.
the Zoom framework screen there.
Yeah, it's on the Zoom screen there.
I'm on the Zoom screen.
Huh. It just went away. There it is.
Chat.
Came back, whatever you did.
Okay, there we go. Okay, chat.
Maybe it's in here.
Okay, someone says no. Anita says no microphone. Can someone ask to read the chat too? Okay. Well, I'm reading the chat. No problem. So, does anyone know about advanced programming course? The advanced programming course question came in. The advanced programming course is ITSE 2347. It is typically offered in the fall, i.e. it's being offered now. It is not down to be offered in the spring. There is another database course being offered that is called, I believe it is Business Analytics. It's basically statistics.
I thought you guys were trying to offer it.
Question is, are we trying to offer it in both sessions? And yes, I am trying, but I don't always get my way immediately on everything. I can hold my breath, but it doesn't typically work. Let's see. Okay, so Union is joining two tables. And then SAS program is important too. I don't teach the SAS programming class. I teach a similar language over at Texas Woman's University called SPSS. SAS is important. I just don't know that particular dialect. First part of the Union is joining two tables. No, joining tables means following a foreign key, primary key. In a union. So I'm gonna push the chat off to the side. Go back. In a union, I do not have a join. I'm not following a foreign key, primary key. I am executing one select from where statement. It could have a where. Could have a where in that. I just don't have one right now. And I could have a where in this one. The main thing is I execute this one, take that output, and then append the output of the second table to it. Question?
So like intuitively is joining like horizontal and union like vertical?
Intuitively is joining horizontal and union vertical. I suppose you can think of it that way if you like, yes. Question was, one of the observed that union is up and down and joining goes across. Yes. Joining puts it all into one select statement, and union says do this select statement and then follow it by that. So it's like running them both at the same time, taking the output and slapping it together, if you prefer thinking of it that way.
Not technically addition, but just combining all them once.
You can,
Is more of
right.
selecting
They are two different, radically different operations. So joining tables is essentially, think of a join as always, what, always? Yes, always, well, most of the time. It means that you're following a foreign key up to a primary key. Okay. So, Okay, I don't see any more chat. Well, we'll use the chat. That'll be fine. Now, if I have an order by, I use the name of the top field. So if I say order by left PK, I can see left PK down there, and it works okay. So order by is going to apply to the entire union. So if I execute this, I don't think it changed anything. I think that's what I got. Let's go. We'll put a descending on it to make it be different from what we had. So now if I execute this, I'm going to see it all ordered 9876 and so on 321. Okay. So if you say order by, you use so the field names in the output will be the field names in the top table. If I switch the tables around, the only thing it's going to change is the field names. And if I alias them, I can make them be anything I want them to be. So it's not, the field names aren't real important. So union does not have a particular order on it. If you put an order by on it, then the order by applies to the whole union. So I can't select from left table, order by something, select, I don't know whether I can or not, but it doesn't make much sense to order by and then add a union to it. I don't think I can say order by here.
Just order half that.
Yeah, I don't think I can order half the table. I think I'm going to get an error here. Yeah, I'm getting an error, incorrect. I'm getting an error right after it.
Did you try the same chart thing?
Well, basically, it doesn't make any sense to order half of a union. You either order the whole thing or you don't order it at all. If you don't order it at all, there's no particular order to it. So these two are incompatible, having them both. I don't know what would happen. Let me just test it here. Let me see if I can order one. I can't order half of it. So you can't kill half a chicken. You heard this joke about the guy who walked into the restaurant and ordered half a chicken dinner. And the proprietor said, yes, sir. And 20, 30 minutes later, he said, well, where's my chicken dinner? And the proprietor looks at him and says, I can't kill half a chicken. That's supposed to be funny. You guys are a tough audience. Anyway, well, kind of funny. Okay, it's kind of a joke. Yeah, it's half a joke. So you can't order half of it. So the order by applies to everything in it. And so there's the syntax. There is
like a where statement could make sense, right?
a where statement on either one of them is legal. Okay. So if I only want, where, let's see, on the left table, it's what is where. Greater than or equal to B, that makes perfect sense. So I'm only going to see A and B so I'm not going to see the left value of 5. So the where on either one of them is greater than B shows me B and C, excuse me, not A. A is not greater than B. Yes.
Can you union 2 or more tables?
You can union as many tables as you want to put into it, so long as you have the same number of columns returned and the columns are generally compatible. Okay, so for example, if you have an integer matches integer, char varchar. If one of them is char and one of them is varchar, put the largest one on top, and I believe everything will be fine. So if one of them is like varchar 16 and one of them is varchar 8, put the varchar 16 on top. Then you order the whole thing whichever way you want to see it.
And you said as long as they have same number.
The same number of fields and the types are compatible. We're going to talk more about what types mean. Right now, I'm going to say the types have to match. There is a little bit of wiggle room in there. A moment ago, you asked me about duplicate rows. Okay. If you just say union, you do not get duplicate rows, no duplicates. If you want duplicates, you add one more word to it, union all, and that will show duplicate rows. I don't have any duplicate rows here, so it won't change anything. But if you say union, you do not get duplicate. It suppresses duplicates. They collapse into one. If you say union all, you will see duplicate rows. Others. You won't be able to tell which table they came from. But questions? If you order by a field that contains null, the nulls, I believe, by default, they have to go someplace, so it puts them at the beginning, I think. I'm pretty sure. It doesn't have to. It will, depending on how your database is set up, on what database you're using, they will either come at the beginning or the end. They'll all come together. So if you're ordering by a field and that field has nulls in it, I believe SQL Server will put them at the end. Okay. Okay. Unions are fairly nice. Now, let me ask you about a full outer join. What does a full outer join do? It shows me everything from the left side and everything from the right side and everything that participates in the relationship. It is not the same thing as a cross join. Okay. So what is a full outer join then? A full outer join is a left join union, the same thing as a right join. So if I union a left outer join and a right outer join, and I'm selecting the same fields, I get a full outer join. This is why most of the time they don't give you full outer join. I don't need it. I have union. I can union a left outer join and a right outer join, sorted any way I want it sorted, and bingo, I've got it.
So full outer join.
I have a chat. Let me take the chat. Ha, 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 ha. Okay. Somebody's laughing at my joke. Thank you, Anita. I'm sorry, go ahead.
So full outer join is a union.
A full outer join, you can, the question was, is a full outer join a union? And I think I can say yes to that. Or is a union a full outer join? I mean, if I have union in all of them, all databases give me union. All databases do not give me full outer join. So if I don't have a full outer join and I need a full outer join, I can build a full outer join from a union. That makes sense? Okay, in addition to union, we have two others. And from the study of mathematics, if you have union, what else do you probably have? What, non-union, union and non-union. Well, is anybody looking at the textbook? And if you're looking at the textbook and reading, glancing ahead a little bit to page 154, you see another one. Intersect. An intersection gives you only rows that appear in both tables. I've probably written in my SQL programming career, I have probably written union 50 or 60 times, I guess, and intersect maybe twice. Okay. You don't use intersect as often as you use union. Union is a lot more common, but intersect also works. What does intersect do? If you say table 1, if you have a select statement on top, and if I change the word union to intersect, I wouldn't see anything because I don't have any values that are common to both tables. Questions? So union gives me the rows that are in either of the tables, that are in either select statement, and a select statement is a table. I'm not sure whether you can say table 1 union table 2 or not. I've never tried it. Try it and find out. I think I have to write select everything from table 1, union select everything from table 2. And if the tables are basically compatible, then I would get the rows. If I just said union and didn't say union all, then intersect, you don't say intersect all. That doesn't make any sense. You just say intersect, you get only one row. So it has to be in both tables, and it presents to you as a single row. Yes?
So you do like right outer join, intersect with left outer join, like you use the inner join.
I'm sorry, I didn't understand the question.
Because you're talking about how a full outer join is the same as a left outer join.
Union, right outer join, and if you're selecting the same fields, yes, go, yes.
So you do like the intersect, left outer join, and right outer join. Is that the inner join?
No, that won't be the inner join. If you inner join, it's just inner join. It's simple.
But wouldn't the intersection eliminate all the parents without children?
Question was, can you come up with using union? Using intersection? Can you come up with the inner join? Maybe. Yeah, it might.
Just like asking like conceptually.
Give it a try and see what you get. I don't use intersect very much. Now the other one that's in there, so there's three the set operations. There's union, intersect, and then there is set difference, and we call it usually it's called difference or minus. Sometimes they use the addition operator, the multiplication operator, and the subtraction operator. So the addition operator would be union, multiplication operator would be intersection, and minus is difference or except. Basically, everything that is in the first table and not in the second table. Okay. Show me all rows from the first table that are not in the second table. So it's kind of like the opposite of an intersection.
But will it show the ones that are in the second table that aren't in the first table?
No. It shows you everything in the top table that is not in the bottom table. If you want it the other way around, you have to write a different one. So I guess you could write that as a union, but most of the time, well, in this class, I'm going to try to teach simple concepts. And if you want to make them wild, you can. Okay. What else? Okay, that is the last one in chapter 4. We are now finished with chapter 4, and it is 11:30-ish. Let's see, my microphones are on, and let's see, I have a message. Okay. Are there any questions about chapter 4? What's the big thing in chapter 4? Joins, inner join, outer join. What am I likely to ask? What will you find when you look at the practice test? You'll find inner join and outer join. Inner join, what does inner join do? It follows a foreign key, primary key. I'm not going to get wild. I'm not going to do anything weird. It makes no sense at all to join my IQ to my child's shoe size. That it doesn't make any sense. If it is not a foreign key, primary key, yes, you can join. I can join on the day of the week to your salary, where your salary is the same as the day of the week, I guess. It makes no sense. So I don't know what you're going to get. But basically, it's a foreign key, primary key relationship is the inner join. You'll see some strange, people will do some strange things. But that doesn't, okay. Outer join. When do we use outer join? Okay, well, if you point the outer join to the parent, you're going to get childless parents. You'll know your childless parents because they have the right side is null. Okay? And so you can filter out the valid children. If you say where the right side is null, I'm only going to see childless parents. And so if you show all of them, I'm going to take some points off. Right? Because if I say just find the childless parents, I don't want to see parents with children. Similarly, if I point it the other way, if I point it at the child table, and by this I mean, I don't care whether the child table is on the left or the right, it's pointing to the child table. So assuming that the child table is on the right, it's a right outer join, I'm going to see all children, and where the parent is null are going to be invalid foreign keys. I would also see where the child is null, where the child's foreign key is null. But that's just kind of, usually if I'm going to make a foreign key, I'm probably going to constrain it against null, unless there's no way around it. Okay. So my foreign key might be your phone number. You have to have a phone number to be in my database. Okay, so I would probably have a parent of orphans in there with a phone number of 999999999. So I can put that in there, and that if you have that phone number, it means you don't have one. But I only got to look at one table for that. So I might ask you to find the orphans. Don't do a left outer join. If I say find orphans and invalid children, now you have to have a left outer join. Because in order to find the invalid children, I have to look at the parent table. No way around it. Left outer join. And if I'm looking for orphans and invalid records, well, I might as well do the left outer join. I'm going to get the orphans for free. Okay. Then we've talked about unions, not as much. So we spent more time talking about the joins, so you'll be expecting more joins than anything else.
So how would you find orphans?
Just orphans, all you have to do is look at the child's table where the foreign key is null. I can see the foreign keys null from just looking at one table, but I can't see an invalid value in there until I look at both tables. I go over to the other table and search it for all the keys, and the ones that I can't match are invalid. So I could do it manually, but boy, that would be a pain. Okay. There are other ways to get it than that, but the left outer join, right outer join is what I want you to come away from this module with. Okay, now if there are no further questions on that, I have made the assignment. I've made both of the assignments due on the 10th. Did I make it due today? I think I pushed it back. I had it due on one class for today, and I think I pushed it back to Friday. Is that a question for me?
Yeah, I think it. Appreciate it.
Okay.
The
Okay.
inner join was due on October 5th.
I think I've pushed it back to Friday. Okay. Because I don't want to grade it right away. I'm a little bit behind. But that's okay. I'll get caught up in a minute. Okay. I don't hold you to a hard date. Don't hold me to it. Let's see. Test. Everybody's interested in the test. The test will be offered online. The test I expect will, let's see, today is Friday. I pushed the inner join and outer join are both due on Wednesday. If you've already turned it in, that's fine. Good on you. You get an extra point or something. No, I don't. Extra points. I mean, that's kind of silly. The test will be, okay, here's what I'm going to do. I'm going to make the practice test due on Wednesday. Okay. I will release the answers to the practice test probably Tuesday. Now, I won't know whether you just copied the answers and turned them in or not. I'm probably not even going to spend a whole lot of time grading your practice test. If you turn in the practice test and it has an error in it, you're probably going to get full credit. Why? It's just something. So I say, okay, you did something, and I want to encourage you to do the practice test. Okay. So you don't have to agonize over, is it right? Just I'll turn in the answers and I will publish the answers, my answers. I get lots of messages about the number of rows returned. If your number of rows returned is off by 1 or 2, particularly if it's a large set, and I say, you know, I got 122 rows and you got 121 rows or 120. Don't worry about it. I probably just made a change to the data. Okay. Your code is correct if it runs on any data. So the fact that the data changed doesn't make your code not correct. It's not about how many rows did you get. It's about, does it logically work? Okay. What I typically do is run it and I look at the number of rows that I got and I know how many I'm expecting. If that's right, I just give you full credit. If it's not right, if there's some discrepancy in it, I go and look at your code. I can usually find it pretty quickly. Let's see, Okay. I think I'm going to make the test available on Thursday. Let me turn on, okay, let me see what's going on here with the chat. Lighten up. Okay, the test on October 10th. Okay, I am, the test is going to be online, so you will be able to take the test online. I think I'm going to make the test begin on October 11th. That's a Thursday. I'm going to leave the test available 11, 12, and 13. So Thursday, Friday, Saturday, I'll probably go ahead and include Sunday. Now, this does not mean that you have 4 days. You have 4 days to take the test. Once you start the test, I used to give 2 hours and everybody complained, that's not wasn't enough time. There will be a time limit on the test. I expect I will probably go ahead and open it up to 3. So give you time to take a bathroom break or something. When you start the test, when you access the test, so if you were to go to your Canvas and there'll be a link there that says, or you open, test 1, And then there'll be a link in there that says you start the test when you follow this link. So you can open it, you can look at the directions and all that jazz. It's just when you click that link that says you are starting the test now, it's red and it says you're starting the test, and now it's time stamped. Now your time limit applies. Okay, so I'm going to leave it available to you from Thursday until midnight Sunday. So you can choose your time. Questions?
Will it be available Thursday morning?
Okay. Question is, will it be available Thursday morning? Do you want to take it Thursday morning?
Thursday morning.
The question isn't so much, it's not so much how long. I think I'd probably make it available Thursday morning at 8 o'clock or something like that. The question isn't how long is it available. I'm trying to give you a time window, but once you start, you have a time, you have a clock. Okay. I do not take kindly if people miss the test. Meaning, oh, I just forgot. Oh, I didn't get the information. You're supposed to be following these lectures and you're supposed to be listening. Not everybody is. Okay. Questions then? I think did I mute everybody? Okay, I'm now taking questions. The microphones are live. I'm watching chat.
I have a question.
Go ahead. This is Doug.
Yes, sir. My question is, where's the test on Canvas? Where will it show up? Will it be a module or will it be somewhere?
Yes, it should be. Let me close this. Under the modules.
Okay.
I'm going to go to it now. After module 6, there is a module that says test 1, review and exam. Oh, I haven't published that, have I? Thank you for asking that question.
Awesome. I was wondering where it was.
I'm going to go continue. Now let me go check inside of here. I want to lock that and lock that. Okay. Inside of here, you got practice test 1. You have practice test 1 discussion. Then I'm going to publish the practice test 1 solutions. Then when you get to test 1, you will see it right here. You can't see these guys, I hope, because they're unpublished. So
That's correct.
1,
they don't show up on the screen.
Right. You should not see these, but when I publish them, so I'll publish the solutions probably Wednesday or probably Tuesday. I'm going to give you a day with the solutions so that if you need to correct something, you can.
Is it writing queries?
Yes. Yeah. I don't do. It's going to look just like the practice test. So if you were to go look at practice test 1 and open it now, you may. The test is going to look just like that.
Which database are you using?
They'll be different. I tell you. When you open test 1, I'm going to go ahead and open it. Okay, do not access. There's some instructions there. You're free to go look at them and read them. And when you follow the link in the next line, you will begin test 1. So don't click on that link until you're ready to begin test 1 because it does timestamp it. Okay. It used to be, last time I had it set up where as soon as you clicked on test 1, it gave you the test. And but I wasn't ready to take the test yet. And okay. There it is. Be ready before you click that one.
Can you take the test more than one time?
No.
It's a one time. Okay.
Okay. I am not. If you take the practice test and then take the test, you will effectively be taking it twice because they are very, very similar.
Okay.
You will not see much difference. What you see on the practice test is what you will see on the test. People who do the practice test, you can do it. It's not a big deal. You don't get a whole lot of points for it, but it's worth your time. Questions? And I see a chat. Okay, who is this? Is somebody writing a chat? I don't see any that I haven't read. I don't know, it lit up, so okay, I'm going to end the recording at this time. Stop recording.